Determine all intervals of increasing trend or decreasing trend and determine the coordinates of all maxima, minima, plateaus, or cliffs for the function f of x equals x cubed plus 3x squared plus 3x plus 5. The first thing to do is find the domain. F of x equals x cubed plus 3x squared plus 3x plus 5 is a polynomial. And a polynomial has a domain that is all real numbers, or negative infinity to positive infinity. The next thing to do is find all critical numbers. We will take the first derivative, f prime of x equals, first term is power rule, bring down the power, subtract 1 from it. Second term is power rule, bring down the power, multiply with the 3, subtract 1 from it. Third term is a constant times x, derivative is a constant. Fourth term is a constant with no x, derivative is 0. We will now fully factor the derivative. There is a common factor of 3 that will factor out, leaving behind an x squared plus a 2x plus a 1, which is a trinomial quadratic, and can factor into x and x. We need two numbers that multiply to be a positive 1 and add to be a positive 2. Positive 1 and positive 1 will take care of this. We can now multiply the two together. Since they're matching bases, it can be written as x plus 1 quantity squared. We can now set the numerator equal to 0, and the denominator, if there is one, also equal to 0. Solve for all x's. This will result in x equals negative 1. We will check to see if this is in the domain. The domain is all real numbers, negative infinity to positive infinity. X equals negative 1 is a real number. It's in the domain. It is therefore a critical number. We can now draw a domain line, a line representing the domain. The domain is negative infinity to positive infinity, so it will not have a left end or a right end. We can put the critical number on the domain, which breaks it into intervals. We can pick a test value in each of the intervals. The interval negative infinity to negative 1 contains the test value negative 10, and the interval negative 1 to positive infinity contains the test value of 0. We can now test the trend in each of these intervals by plugging these test values into the first derivative. We only want to determine whether it is positive or negative here. It doesn't matter the value. So we will plug these into the factored version of the first derivative. Starting with a negative 10 plugged in for x, negative 10 plus 1 is a negative. Negative squared is positive times a positive 3 is positive. So there will be a positive first derivative in this interval, which corresponds to an increasing trend. Now the 0 can be plugged into the factored version of the derivative. 0 plus 1 is a positive. Squared is still positive times positive 3 is still positive. And we will have a positive first derivative in this interval, which corresponds again to an increasing trend. So we have an increasing trend from negative infinity to negative 1, and again from negative 1 to positive infinity. Right at negative 1, it does not have an increasing trend. That's why it's round brackets on the negative 1. It's not included in the interval, and there are two separate intervals for this reason. And there is no decreasing trend for this function. Since there was a trend that didn't change at the critical number of negative 1, and negative 1 came from the numerator of the first derivative, negative 1 will be a plateau. And we can find the corresponding y-coordinate by plugging the x-coordinate of negative 1 into the original function, f of negative 1, which will be negative 1 cubed plus 3 times negative 1 squared plus 3 times negative 1 plus 5. Negative 1 cubed is negative 1. Negative 1 squared is positive 1 times 3 is a positive 3. A 3 times a negative 1 is a negative 3, and then plus 5. The 3's can cancel, and negative 1 plus 5 equals 4. Since the trend didn't change, we have a plateau, and it was occurring at an x-coordinate of negative 1 with a corresponding y-coordinate of 4.